Hello, Algebra 2. This will be day 2 of geometric sequences and series, and today we will look at a series. A series is the sum of the terms in a sequence. So if we have a sequence that is geometric, the series is when we take all of these terms and we add them up. So 2, 4, 8, and 16 are going to add up to a total of 30. And in a sequence, in a series, we have a couple of formulas that we can use to find the sum of all of the terms. So our first formula uses a sub 1, r, and n. So this formula is used when we know the first term and we know how many terms. So using our example from above, we know the first term is 2. So the sum of those 4 terms is going to be 2 minus 2. And our r value is timesing by 2 is our sequence we're following. Hopefully you can see that. So we have 2 minus 2, there's our first term, times our r value, which is 2, raised to the 4th power all over 1 minus r. And I don't have the ability to put that into my calculator at the moment. But if I take 2 minus 2 times 2 to the 4th power and divide that by 1 minus 2, I will get that exact same sum of 30. And then the second way to find the sum of all of those terms is if I know the first term and I know the r value, and if I know what the last term is. And to find the sum of the 4 terms, I would take my first term minus my last term, which is 16, times my r value, which is 2, and divide that by 1 minus 2. I'm doing a quick little bit of arithmetic. 16 times 2 is 30. So 16 times 2 is 32. 2 minus 32 is going to be negative 30 over negative 1, which does add up to 30. So depending on what parts of the sequence we know, if we want to add it all together as a series, we would use one of those 2 formulas. Secondly, when you're adding things together, it's oftentimes using a summation symbol. So this is called sigma notation. So this E-shaped letter here, this is a Greek letter for sigma, and it represents that we're going to take some sequence that can be represented as a function. We're going to add all of those terms together. So some key parts of the sigma notation is at the bottom part would be the first term number that you would use. So here k equals 1, that means I would use a sub 1 as my first term. And the top number then represents the last term that you would use, which would be a sub m. And this represents the rule for creating the sequence. And that would be our explicit form. So our rule for creating the sequence. And that's just communicating to us to add up all of those terms together and find their sum. So here's an example of a sigma notation. We're going to add the terms from a sub 1 to a sub 8 using the rule 5 times 3 to the k minus 1. And to do this, a sub 1 to a sub 8, we're going to be adding all of these terms together. So to find this very first term, this a sub 1, I'm going to take a 1 and put it in for that k. So this would be 5 times 3 to the 1 minus 1. It ends up being 5 times 3 to the 0, which is going to end up being 5, because 5 to the 0 power is going to end up just being 5. This next term is going to end up being 15. This next term is going to end up being 45. This next term is going to end up being 135. and then this next term is going to be 135 times 3, which is 305. And then I would add all of those terms together. Now keep in mind, I would add up all the way to a sub 8. So I would add up all of those terms together. But luckily, just like we saw on the previous page, we do have the ability to use one of those sum formulas so that we can add this together a little quicker. So in this sequence, I can find out that the first term is going to be 5. The R value is going to be 3. And then I also know the number of terms from 1 to 8 is going to be 8. And so going back to the previous page, I could use this formula to figure out what the sum of all 8 of those terms are. So I wouldn't have to go through and add up each one, figuring out all those. If I know the first term, I know how many what we're counting by, and I know how many terms I have, I can add all those up using the sum formula. So I would use the sum formula. We're heading to example 7. Katari wants to set up some dominoes so that she can knock over 1, which is going to knock over 2 more, which knocks over 2 more, and so on. If she wants to make 6 rows of dominoes, how many will she need in total? If we have a domino set up, it's going to knock over 2 dominoes, and then that domino is going to knock over 2 more, and then that one's going to knock over 2 more. We're going to start to see this sequence. So 1, 2, 4, and then our next row is going to be 8, then 16, and we want to add up a total of 6 rows. So ace of 1, ace of 2, ace of 3, 5, and then 32 is going to be ace of 6. Now with only 6 rows, we could just add these together. So these are going to add together to 15 plus 16 is 31 plus 32 is going to add up to 63. But why don't we try out our sum formula? So if I have a ace of 1, which the first term is 1, the R value is we're timesing by 2 to get to each new term. And lastly, I know my number of terms is 6. So I can use this sum formula. Ace of 1 minus ace of 1 times R to the n all over 1 minus R. So the sum of those 6 terms is going to be 1 minus 1 times 2 to the 6th power all over 1 minus 2. And when I figure that out, we end up doing 2 to the 6th, which is 64. So you end up getting negative 63 over negative 1, which gives our exact same sum of 63. Now, I wouldn't recommend doing that by hand. You can just plug that into your calculator and you'll get your sum of your value. Next, we're going to use our sum formula with knowing the sum to find the first term, or find the a sub 1. So we're going to find this first term. So looking at the information I'm given the total sum. I'm also given the total number of terms, and I'm giving the R value. So I'm given the total number of terms and the R value, and I need to find the first term. I'm going to use again this top formula. So this, I know the a sub, I need to find the a sub 1. I know what the R is, and I know how many terms are in my sequence. So we're going to use this formula. A sub 1 minus a sub 1 times R to the n all over 1 minus R. We have our sum, which is 21.3125, and that's going to equal a sub 1 minus a sub 1 times my R is 1/2, and I have 5 total terms, all divided by 1 minus 1/2. So looking at that, I have everything filled in except for these a sub 1s. I need to do a little algebra to figure out what a sub 1 is. Now, since a sub 1 is in common between both of those terms, I can factor out an a sub 1. I'm going to take 21.3125 and factor out that a sub 1, and then this would be 1 minus 1/2 to the 5th, and I would factor out that a sub 1. So when I divide an a sub 1 by a sub 1, I'm going to get 1, and then when I divide that a sub 1 out, it just ends up leaving me with a 1/2 to the 5th. And then lastly, underneath here, I still have a 1 minus 1/2, which let's just change that to 1/2. So now I have a little bit of algebra to do. I'm dividing by 1/2. So to undo that, I'm going to times by 1/2. We times both sides by 1/2, and that's going to undo this divide by 1/2. And we end up with 10.65625 is going to equal a sub 1 times 1 minus 1/2 to the 5th. And we're still targeting this a sub 1, so a sub 1 is timesing all of this stuff, so we're going to divide by all of this stuff. 1 minus 1/2 to the 5th, and over here we'll divide by 1 minus 1/2 to the 5th. And when we take that result, that 10.65625 divided by all that, we are going to end up with our a sub 1 is going to equal 11. All right, and then lastly, we're going to find a sum in sigma notation. So we're going to find the sum from the 5th term to the 7th term of this rule for my sequence. So I have two sum formulas to choose from. So one formula, if I know the first term, I know the R value, and if I know the total number of terms, I can calculate the sum. And using this sigma notation, I can find the first term I need to add up. So this first term I need to add up is going to be a sub 5. So this 5 to 12 is telling me we're going to add up a sub 5 plus a sub 6, a sub 7, all the way to a sub 11 plus a sub 12. But technically this 5 is a sub 5. This is the first term I'm going to add up. So I'm going to add up from 5 all the way to 12. So to find that first term, I'm going to take the 5 and I can put it into my function up here. So to find a sub 5, it's going to be 3 times negative 2 to the 5 minus 1, which when we calculate that out, that first term is going to be 48. The first term I'm adding is going to be 48. The next thing I'm going to need to know is how many terms there are. And when we count up from 5 to 12, that's going to be 8 total terms. So you might be thinking just 12 minus 5 gives you 7, but when you include the 5, that's going to mean that you have 8 total numbers that you're adding together. And then lastly, our R value. So our R value is right here, is equal to negative 2. And with this information, I've got the 48, I've got the 8 with my total number of terms, and I've got the R of negative 2. I can now use this sum formula. So to find the sum of these 8 terms, I can take 48 minus 48 times negative 2 to the 8, all over 1 minus negative 2. And once we add all that up, or we put that into our calculator, we will get negative 4,080. So those 8 terms are going to add up to that value of negative 4,080. So that wraps up day 2 on adding together the numbers of a sequence, which is called finding the series.